Yes. Okay. So let me get out of the way over here. So Devin and Trevor, they're over here. That's Trevor. That's Devin. They look very similar. Anyway.
They're far enough away I can't see them anyway, so it doesn't matter.
Okay. All right. Well, so let me. Anyway, so
because you're presenting, I get this teeny tiny screen. That's what's. Okay, I'm gonna need a volume now. There's the team. I can't hear y'all at all anymore. Phil broke it.
Test.
Let's see.
There you go.
Okay, sorry. Okay. So listen, so you can drive there. It's recording. Here, you sit here in this chair. I'll sit over here with my coffee. You drive.
Okay. So what I was thinking of, usually when, I mean, this is like on the fly. I don't like know what I'm doing, but the best way that I know of how to like engrain something is to get your hands dirty, and so that's what I was thinking of doing. And so I don't know what.
In other words, he wants you to drive, Phil.
Me?
See, it's a question of, do we want it working or do we want Phil driving?
Yeah, those are mutually exclusive options. You know that.
Oh my gosh, this is.
Just don't tell any of your customers.
This is a very delayed mouse.
The fine print.
Okay, that machine is still running. So, okay, to give you a little background.
So you're not sharing the screen. You know?
No, not yet.
Okay.
I will eventually.
Okay, cool.
I didn't realize how.
Oh, you can get rid of that. I don't care.
I didn't realize how delayed this mouse is compared to.
So move the mouse out a little bit. Sometimes it gets move. There you go.
Would you rather?
Just say no.
That's a little better. No, I think it's the wire connection. Oh,
Yeah, I mean, like,
that might be better actually. Yeah. Oh no, I don't want to cancel this.
Password.
Yeah.
They're gonna give us an overview, Bob, of what's going on. I'll be learning the most. Maybe me and you. Jason already knows this, and these guys know it. So anyway,
no guest edition. Can I share my screen?
Yes. So you know how to share your screen?
Yeah, I just gotta get to the Zoom window.
Yeah.
Oh, is it that? Oh shoot, this is taking up.
It's all right.
Sorry, this is so on the fly.
Oh, here, no,
I don't know how this is gonna work.
That's all right. Yeah, make this big, and then share screen.
Yeah, this is a lot of delay. Can I get your mouse? I want to share this. Share. So what I'm sharing now is just a VM, and we haven't even installed anything on it. So I'll install Docker and stuff on this real quick.
This is what is it now? This is a
Debian VM that's running in VirtualBox. Okay. So yeah. I don't know how much.
No,
So you use Proxmox, right?
Yeah.
Use the virtual environment one.
Here.
Yes.
Okay.
Yeah.
It's got a pretty long cable, so.
Yeah, and I did the base install, which comes with Debian. I know you can install it on top of whatever Linux, but I just let it do the OS install too.
Okay. Does it use
libvirt for its
You plug
virtual
it in
machine
there?
stuff.
Yeah,
Upper left one?
That makes sense.
I've started using that. I think by default, I think it was.
Oh, using a KVM.
Well, at least for the
yeah, and I gotta be
console, it's
careful 'cause
Spice.
You plug it in the
Does that
wrong
make
thing,
sense?
and it's
Yeah.
a government computer. then
Spice versus
it
Libvirt.
locks my
Oh,
computer.
is it Spice? Spice is like the window like server, the display server sort of thing for like the virtualized stuff.
Yeah. So by default, well, okay, so that's just for like console access, right? So by
Well,
default,
you can
it
use it.
does
It's like the desktop, like the Spice
Looks
server
like
is
it
like the
would.
window, like.
that. Oh, okay.
manager.
The mouse is ready.
Oh, sweet. Oh, yeah.
Oh, whoa. Is it faster?
It's the sensitivity is definitely higher. Okay, so just to give an introduction, there are no such thing as containers. I know that sounds weird, but all containers are Linux kernelisms. So the Linux kernel does some stuff under the hood that makes it look like containers exist, is what I'm saying. So yes, in the high level, containers exist, but the low level, it's just a bunch of syscalls that do stuff.
Basically, containers are an abstraction of kernel features.
So the Linux kernel, let's give you a little history, about a while ago, I want to say 8 or 10 years ago, don't quote me on that though, there's some developers from Google who introduced these things called namespaces. Okay, now what namespaces allow you to do is separate certain groups of I don't want to say resources because that makes me think of RAM and CPU, but for example, there's a PID namespace. PIDs, if you don't know, are process IDs. Okay, so when you create a new process, when you start a new program, the Linux kernel will assign it a new process ID that's unique to that process. Okay, and typically you can run a program like top and see the list of all the PIDs running on your system. Okay, that way you can, if there's some process that's hanging, you can see, okay, it's this process. Okay, kill that with this PID. Okay, now what namespace? So once the namespace is introduced, you can actually separate groups of PIDs. So for example, if I create a new PID namespace and then start a new process in that namespace, it will give it the first available PID, which in that namespace is 1, because it's the newest PID in this namespace, which when you're in that namespace, you can't see the outside of that namespace. You can only see the inside. Okay. So PIDs are just one of the resources that we can apply the namespace concept to. There's also networks. So you can have different networks inside of your namespace that are separate from the networks on your host computer. Well, even the term host computer is kind of fuzzy there because it's still running on the host computer. And even when you're in a namespace, that PID is mapped to the main namespace. So even though in this namespace my program has PID 1, it might have PID 10,256 on the host machine. It still exists there. It's just mapped basically in. And the reason for that is you're using the same Linux kernel on the outside as inside this namespace. Okay, that is the basic idea of a container. Is Docker is basically a wrapper around this namespace thing that allows you to separate or isolate certain resources. There's also another kind of equivalent idea of namespace called control group or C group. Now, it's also another kernelism, and C groups are basically the same thing, but for like hardware resources. So if you want to say have a group of processes using only 2 CPUs, then you can use C groups for this. It's basically the same thing as namespaces, but for hardware resources. Okay. Now, I will start installing Docker on here real quick because I probably should have done that while I was talking. Okay, this is, and I apologize because I have no idea what this meeting was going to look like until right now. So I'm doing my best to make it seamless. Yeah. How do what's the Windows start taskbar? It's not coming up anymore. Okay, yeah, I need to get to the browser.
It's not going to be shown, so I'll just go to, okay. So I'm going to install Docker on,
So what I was
Debian.
gonna say is if you just share the whole desktop,
Oh,
then
okay,
whatever
yeah.
you have.
let me share the whole desktop so you can see what I'm doing.
You're going to stop this share.
Oh gosh, that's slow.
What about your documents though?
I don't care.
Screen. Sure. Okay, Bob, can you see my whole screen now?
Yes.
Okay, cool.
Yeah. Now I got your browser.
Gotcha. Okay, so what I'm going to do is install Docker on Debian. Okay, and this will be recorded so you can see how to do it. You can follow along if you want. But this site is actually a Docker official documentation site, docs.docker.com. Okay, and it's an article on how to install it on Debian. And the newest stable version of Debian is indeed 10, which I think is Bullseye. I can't remember. Oh no, Buster. Bullseye's the testing. Okay. So basically, I'll go through these commands and I'll explain what they do. So there's another thing that I need to explain. Well, I don't need to, but I want to right now because this command right here will install Docker and its dependencies on Debian via the Debian package manager, which is apt. Okay.
That removes all.
Oh, sorry. This is
That's
removing
yeah.
stuff. Yeah, never mind. Not that one, but this one does. It will actually. This is going to install HTTPS TLS stuff so that we can use TLS to get images from like Docker Hub and stuff. So sorry, I'll explain what I was going to explain, but I'll explain it later. So first thing I'm going to do is install these packages, which are, you see CA certificates, curl, apt transport, HTTPS. Those are all so that I can use TLS, HTTPS to query Docker APIs like Docker Hub, and if I want to have a registry of images, which I'll explain that real quick. So if you've ever heard like people talking about Docker containers and Docker images, here we go. No, wrong one. You might be wondering, okay, what is the difference between a Docker image, an image in a container? Okay, and the analogy that I like to give is if you have a program running, okay, that program is an instance of the code that was written to run that program. So the code itself isn't the running program. It's like basically the blueprints for the program. And then you have the program itself that's running, which is like a process that has memory allocations and all that stuff that are associated with that process. And that's the running instance of your program code that you wrote, right? It's analogous to the difference between an image and a container. So an image is like the static blueprint definition of like a container, which is a running instance of that image. So a container can be modified and change over time, whereas an image cannot. And depending on how you have the container set up, once that container stops, those changes will disappear. If you've ever heard a container being ephemeral, this is one of the powerful things about containers is what you can make changes in a container, and depending on how you have it set up, if you mess up something, oh shoot, I made this change that a while back that I don't need, that I can't go back and change, but I also have all this other configuration stuff before that I don't want to have to redo. Well, if you have all of that stuff in the image definition and those changes that you made were here, then you can just restart the image. We basically make another instantaneous instance of an image, and all those changes you made will disappear, and it'll be that hard work that you previous did, and that's useful for if you have a group of software that has very specific dependencies that need to be exactly right or else it won't work. You can package that up into an image, and then you run the image as a container. You do some stuff, you're building something else. Oh shoot, this isn't working. I need to start over, but not completely over from the build of these packages. Okay, just make a new instance of this image. Boom, I'm back to where my start of the changes happened.
It's our CMDB sandbox.
Yeah.
Yeah, really.
And what's interesting, what Docker does is Docker actually implements what's called the Open Container Initiative, which is an open standard of how containers should be implemented. That's not an implementation; it's a standard. So there's other container runtimes like Podman or Charlie Cloud or Builda, which are, and Docker is actually another container runtime. But those all follow this thing called the OCI, which is the standard of how the lifecycle of containers should look.
What does OCI stand for?
Open Container Initiative.
Okay.
And Docker under the hood uses this program called runc, which follows the OCI. And I can't remember where I was going with this. Anyway, I'll keep
pull up that.
So this is so Bob and Jason and I deal with the CMDB, which basically has its golden data set, which is your standard, right? And then when if we go make a change to it, we basically make a change in our copy of it, which is our sandbox, and then we can decide to promote that, or we can decide to throw that away. So that's how, because I've been in the CMDB all day doing this stuff for the Pentagon, so that's how I'm equating this to me. And I don't know if that makes sense to Bob, but Bob probably understands this better than I do because they have Linux, they run like you guys anyway. So this makes sense to me. So the image is the definition, and the container is the instantiation of that image.
Yes.
Container is
Yes.
an instance of the image.
Got it.
And so you
Same
can
way
actually have
that
multiple
process is
container
an instance of a
instances
program.
with different names, which under the hood will have different namespaces if you so choose. So I will go over that once I install Docker. So let me continue that process.
And so is that how, and I'm assuming this is some managerial hypervisor thing, how you can, I've heard that you can tell the process that controls the instances of the containers, you manage it to say, hey, look, if this container gets to a certain CPU utilization or disk utilization or whatever, clone yourself and make another one. Or if this gets corrupted, just drop and then start another one. Is that, am I?
That would be the orchestration part of containers, like
Oh, okay.
Kubernetes.
Okay.
Oh, is that Kubernetes?
That's
Okay.
that's
Sorry,
after this.
We will talk about
That's definitely-
Kubernetes
Okay.
separately.
Okay, so this is the mechanism of creating a container, right? You manually run the tools to create the container. You manage them through the command line, right?
Got it.
Then there's how do we scale this? We want to run the containers on this huge cluster, right? And we want them to be able to restart if they fail.
Yeah.
That is where orchestration comes in. Okay, you have the tooling to create and manage containers. Now, how do you orchestrate them automatically? That's where Kubernetes comes in.
Got it.
So, but what we've been going over is really the foundation of why that all works, right?
Yeah,
Yes,
because
we're starting from the very
Exactly.
bottom
So-
so that you understand what's going on, and then we'll work our way high level.
So the ability to have the image and instantiate whatever you need, that's the orchestration that will later handle that. Right?
Yeah, it's like you have these images, but then you can the orchestration mainly controls like the
Sudo apt-get. You missed the apt-get at the front.
but this is kind of like
I'll
the
get there, Bob.
magical machinery.
No problem. Just helping.
Yeah. Okay.
Thank
cool.
you. Yeah, so you notice I'm saying apt install versus apt get. So there's different wrappers for the the apt package.
Okay.
Apt get is like is
You get nice colors if you use apps.
you get nice colors if you use apt instead of apt get. Basically, is why I'm using that instead.
Gotcha.
So, PG and then LSB release password. We're secure here. We always have security in mind.
Hey, I was told this was a crash and burn system, so I wanted to make it available.
Mhm. And see, Docker uses a GPG key so that we can verify that they are who they say they are. And also security in mind, we're taking the output of a file on the web and doing stuff with it directly, which is always good.
Mhm.
Well, you guys think GPG is not like
Yeah, it's not like you're passing it to a shell, so that's fine. I pasted already? Maybe not. Oh wait, yeah, I need to figure out what's going on with this clipboard thing. Oh wait, it was under view? No, it's under devices.
undo?
Yeah, there we go.
You have guest editions installed?
Oh shoot, we don't have guest editions installed. We didn't do that. That's why. So bear with me. I'm gonna have to type this all out, which won't take too long.
So Bob is actually the one that Bob hired me to do stuff that he could have done in his sleep. But since Bob hired me, he could do other stuff. And it's Bob's money that actually bought the server over here.
Oh,
So
nice, Bob.
we can
I'm
thank
not-
Bob for having the server.
I wouldn't say it was Bob money by any means.
It's money
Bob was the
that,
conduit.
well,
It's all of our money, right?
yeah, no, actually, Bob's the one that said, I don't want Phil.
She's a shit.
By the way, Bob's way smarter than Phil, but Bob told Phil what to do and Phil did it.
Yeah, but-
Phil's, I was gonna say teachable, but that would be a little, I don't.
Yeah, but what was great was Phil did exactly what I needed him to do,
Perfect.
as opposed to my other Remedy developer, who goes off and does whatever they want to,
As
and then I have to go back a couple of years later and rebuild it.
This thing is surprisingly quiet. I'm sure once you put some load on it, it can hum, but I can bear that's quieter than mine right now.
Oh, you know what?
Is it even running an OS right now?
It's not, he's
yeah.
got a thing, he's got his drive plugged in. I'm actually gonna move it over
Yeah, I'm
here.
gonna say, I think it's just in the BIOS.
Oh, okay.
That's why.
That might explain
So,
it.
should we power it down?
Yeah, you don't really need to because you're gonna have to power it down anyway to boot into the
Okay,
boot
okay,
menu.
because he's doing.
So what
most
I'm-
of his
So
showing.
never mind. You're actually in the menu. I'm not gonna touch it.
You're almost there, yeah.
What I'm doing next is I'm going to add the Docker repository so that apt can see it, so that when I update the system, it'll see, okay, we can, it'll be able to see, oh, there's a Docker update, something like that. So I'm adding the repository with this command. Oh shoot, I'm gonna have to type this all out. To apt, so apt can see it. Echo.
Oh, configuring app repositories.
Okay,
logged into Git one time, and
I would have already lost my mind not being able to cut and paste.
What's that, Bob?
I would have already lost my mind not being able to cut and
Oh,
paste across here.
yeah, I know.
Well, Phil, what
I should have spent more time on this earlier. Oh well.
Get lab self hosted. Get the
Yeah, it was a few years ago.
Docker archive.
Or I would have spun up a browser in that window and then cut and paste.
Yeah.
I can teach you that. I'm pretty good at Git actually.
Yeah, Devin. I go to Devin for my Git questions. So
A
I
lot of
get
it has just been like troubleshooting complex
archive.
Git history problems.
Huh.
GPT.
So Bob, in case you didn't know, you're a Star Trek guy, right?
Yes. Oh yeah.
You remember the Binars?
Yes.
Devin and Trevor are the Binars.
See, Docker archive.
And I say that in love, by the way.
This is the.
Remember the Binars?
It's been longer than this Star Trek. Is that like the original one?
They're I forget what about
So-
but they're
So, it,
yeah.
so Phil, that makes you a tribble then, right?
No, I hope not. Yeah, Binars were like these two people, but they basically shared the same mind. And one would start a sentence, and one would finish it. And they would say, "Oh yeah," blah, blah, blah," and they would have this little, 10 gig pipe between the two of them that nobody else could was in, and they're like, "Oh yeah, okay," and then and you're like, "What just happened?" So yeah, that's these guys.
Okay. So let me see that pop real quick. Cannot type. Oh, yeah. Let's see there.
It's kind of annoying. It's like sudo t to dev null if you want to redirect to a file as root.
I didn't add this in the file. That should be in here. You know what? I'm just going to type it in manually here. Do you have Vim on here? Hopefully you do.
definitely VI.
Sorry, it's taking so long. Yeah,
Capital G.
Huh?
Capital G and an O.
I know. I'm in like a.
By the way, Bob is the one that brought up the certificate thing.
Oh yeah. I've done everything except set up an actual authority. Like I've done certificate signing, of course, all that stuff. Basically, you just need a self-signed certificate that's trusted on each of the clients. If you want like an easy way to do it, you could just get a Let's Encrypt certificate because they do signing for free.
Yeah.
But if you want to spin up something quick and convenient, that's probably a good way to do it. Otherwise, if you want to learn about it, you can get in there and get dirty and set one up.
That's my plan.
Okay.
Because I've got.
I'd like to learn about that actually, so that'd be fun.
Yeah, if we dive into that, that'd be cool. Because yeah, I've got one VM with it's a container, my Jitsi
Oh yeah.
server using Let's Encrypt.
Oh, you use Jitsi, huh?
Yeah, but that's the only one I have exposed to the internet, and to keep the cert going, it has to Let's Encrypt has to be able to connect back. So
Okay.
none of my other ones, like I'm using
For the challenge
Unify.
and stuff.
Yeah, exactly. So yeah, so I want to get rid of all my untrusted certificates, my Unify web management interface and various things. I don't want those exposed to the internet. So that's why I'm thinking, okay, I'll just stand up a CA and put the root cert on all my machines, and then everything will be trusted.
Yeah. Use Jitsi to like voice chat with friends and stuff.
Yeah.
Like whenever you do you use Matrix as well?
No, I'm not familiar with that.
It's kind of like the channelized text messaging.
Oh,
Like it's like distributed and stuff, and it's in free and open source.
Okay.
Matrix is like the implementation of the. Wait, Trevor, what is the actual spec called?
Matrix.
Oh,
The
Matrix
implementation
spec?
is called Synapse.
Oh, okay. I always get the terms mixed up for that. But
Make this window slightly bigger.
we have one set up on
There you go.
his server at home. And it's like different clients you can get, but Element is like it's cool because you have like channelized chat and it's self-hosted, and it's like you can have different rooms and things like that, and you can have a Jitsi integration into that too.
You can see that fine, Bob?
Channel.
The text on the
you can have
screen?
a general channel.
Yeah.
Okay, cool.
Jitsi widget in there. And we just
Let's
like
see.
can join that.
Okay, so
Kinda
now
like you can on like Discord or something. We can just like join.
Yeah.
Like Teams, we can join
make this
the one like on that room or on that server.
this mouse is so
voice
sensitive. I
chat.
gotta
yeah, that's pretty.
Yeah,
I didn't know
but
that
it's
was
like
there.
self-hosted, it's pretty neat.
Cool.
So now that I've added the repo to apt, I have to actually make apt see it. So sudo apt update malformed entry. That's probably the one that I made.
That ET app source that list. Oh, never mind. Fix that.
Make sure I entered this right. This is a silly problem, so unfortunately.
One reason not to use apt.
User shared keyrings docker-archive-keyring.gpg. Yes, download.docker.com Linux Debian stable.
I think I have a VMX image, a VM image
You know what?
of
See? You know where it is?
it's on that laptop over there.
Well, we can take that license and whatever system we put it running on, we can just use that same MAC address. Well, is it licensed?
I think so. I think I
It's
got it
licensed.
from EMC.
Okay, and that could be the license that's been the missing key.
Well, the problem is that the VM version of VMX, so the version of VMware on there, VM, whatever it is, isn't compatible with the current version of
Extension pack. Here we go.
OS X.
Okay.
So I'm not sure
So he didn't load the extension pack.
No, very quickly did this so Phil could get back to work today, and I didn't know what I was presenting with this VM, so we'll do that real quick so I don't have to go crazy typing out everything. Yeah, I agree. I'll just finally agree.
You a Mac guy, Jason?
I'm not sure if I have to restart, but let's see.
I know very little. I have one for work, but I'm not. I like the idea that it's.
Okay. So let's see if this will copy and paste. Shoot, did I click? Okay, let me restart
You-
VirtualBox. I think I have to restart VirtualBox.
Yeah, I think you had to restart VirtualBox for that to kick in.
Yeah. Let me actually see this first.
Because I know there's a way to convert a VMware image or a VM into Proxmox, but I don't remember if you have to export it.
Yeah, I think you have to export it as an appliance, and
That's what
then
I'm
you can.
wondering.
Yeah.
So you have to be able to actually connect. Yeah. Well, if you can download, what did you say?
Oh shoot! Did you put this on your desktop?
Is that what?
Oh, good, you did. Okay.
Yeah, because I think you have to put OFEs or the virtualizing the
Appliance thing
Yeah.
extension. Like
OVA.
OVA.
Let's see if the resizing worked. Oh, not that one. Oh no,
Does the guest have the guest editions as well? Oh.
it does not yet. Oh, let's see.
Yeah, I think you. There you go.
So Bob, what's your background with this stuff, with what you do and all that?
So I have been a Remedy developer and admin since 1999.
All right. Definitely tenured.
Always had it running on Linux or Unix, one of the two. And
Like
always used Oracle as our database.
okay. Which Unix implementation did you use?
So we used to use God Almighty, a long time ago Unix.
Like the AT&T Bell Labs Unix?
No, this was the real Unix.
BSD or something.
Sun.
Oh, Sun. Oh, sure. Which
Oh, Solaris.
Solaris.
yeah.
Solaris. Yeah.
Why is it opening in LibreOffice?
Script.
No, bad. I can't remember. the heck is this thing doing? Should have opened the script. Oh, that's why it's freaking trying to load leave Rob.
Yeah, back in the day, the Army did not care for Linux.
Oh, really?
Yep.
Was it a little too Wild West?
Well, it's because it came out and it was free, you know,
Yeah.
to get a hold of it, and then you'd pay somebody for support, but you were really running freeware with support, and they just did not care for that.
This whole idea of free software is
I think they've embraced it a lot more now.
Almost not a choice anymore.
yeah.
Yeah.
Shoot, even Windows is, hey, we have a subsystem now.
Yeah.
But
Actually, I read that they're actually trying to implement eBPF in the Windows kernel. Really? What?
What's that?
eBPF is like what would you classify it? So eBPF stands for the Extended Berkeley Packet Filter. Its original intent was to on the fly have programmatically and control network interfaces, but it evolved. The extended one is evolved to be able to send arbitrary bytecode to it to programmatically do a lot more. So you can actually use it to probe certain Linux functions, and print out when something is happening on the fly. It's like a way to like manipulate kernel structures without like changing the code.
Really?
Yeah. I haven't. He's used it more than I have, so he has a better understanding of it. But it's like widely used among kernel developers, and then I guess Microsoft developers were like, "Hey, that's a good idea." Oh wait, no. Yeah. Well, I'm just waiting for the Microsoft Linux distribution to come out.
Yeah.
I think that's what WSL will be. Let's see which one would be. Supposed to be records. Household records. That's funny. This definitely looks like something. Bob, has anyone ever told you that you look a little bit like Linus Torvalds?
like who?
Linus Torvalds, the creator of Linux.
No, nobody's ever
Really?
said that.
I mean, at least on the screen that I see you on, you look a little bit like him.
No, nobody's ever said that.
It's first for everything. Magnesium keyboard. Let me get my coffee over here real quick. Some coasters over here.
So the cert stuff it had us download right off the beginning, is that just with all the typical CA?
The CA certificates is like the one
All
that
the trusted.
has all of the trusted certificates. Yeah.
So like
Yeah.
the CA search you get with the Java, that key store, it just has all the well-known CAs in it.
Yeah, like the one like your browser users and stuff.
So Debian wouldn't have that out of the box.
Well, it has
The
the
limited set.
it has the where is it? It's the SSL certs, and then CA certificates are stored there.
Uh-huh.
I'm not really sure.
You had to like install
I think
CA certificates now.
I think that one is specifically for like the Docker registry stuff.
Oh, okay.
I think because obviously you were able to get to the Docker site just fine. So,
But you downloaded the CA-certificates package, which
Yeah.
my
It didn't
understanding
look-
maybe
that
you're
that
right,
was the
maybe.
regular certificates that you get.
I wonder what that package entails then.
That just caught my eye.
Doesn't have can do Lux on the init ramfs.
Oh yeah. Doesn't have any.
Fortunately, we only gave this VM like 2 gigs of RAM, so and like a single core.
Hmm.
Actually, let me see. Oh yeah, single.
Is it only a quad core?
Why is my mouse escaping? Okay, I gotta install or restart. So restart.
Shut down and then restart. Oh, guess not. Just
I'll
kidding.
just yeah, I'll just
Usually has.
open it.
It'd be a good time to give it more resources if you want.
Yeah.
Oh shoot! Dang it.
Yeah, it starts it.
Oh, not here we go. I'm gonna do that.
ACPS shut down. You should be able to shut it down while it's booting. Okay, yeah, it's just grub, so it won't corrupt anything.
So I'm downloading 4.1.4 of VMware Fusion, so I should be able to open that VM, and then we can get the license key
Yeah.
or whatever,
Yeah.
if there is one.
And if you, I mean, it was an 8. Is that one 8.1 or did you have multiple?
I have multiple.
Okay. Because yeah, if you could get it working in Fusion, you should be able to export it and you can bring it onto the server if you wanted an old reference system.
Well, but if we're running Proxmox on there, how do I take a VMware image? Do we create a container?
No, Proxmox runs virtual machines too.
So if I take this VMware image, the VMX files,
Well,
the
that's
mailing.
that's why I wasn't sure. I don't think you can take the files directly. You would have to export it from into a standard.
export the image,
Exactly.
export the VM,
Exactly, and it's
into some portable file thing or whatever.
OVA.
Something.
yeah
Appliance.
Yeah, appliances, OVA. So it's a common file that you can import into different hypervisors.
Oh, okay, cool.
And
Oh, and then we
Proxmox being
put
a
it-
hypervisor, exactly.
Dude, no way.
And that's what I love about having my server, because I used to have, just like you, all these Remedy VMs, and you fire it up and then you can't even use your browser because it's just chugging away.
Right.
I put them on the server. Let that chug away.
That's why I
Yeah.
use this on it's way better on a Mac.
Oh, really?
It's way
Oh,
way
I guess
better on a
makes
Mac
sense.
than it is on a Windows. The Windows VM image of ITSM is way faster on a Mac than it is on a
Really?
Windows
That's
machine,
funny.
which is why I bought this. And with the big 17-inch screen, I want to be able to use Dev Studio.
Heck, yeah.
The
So now-
studio, the 90E.
Yes, it's the
It's Eclipse.
Eclipse.
Oh, okay.
Yeah, it's a
Java, basically.
Yeah, exactly. It's all Java based. Yeah. There's still inside of Remedy still some C components, but
Yes,
they've been
finally.
working
It's
on
working.
making it all Java.
Oh, they're moving to Java. Okay.
Yeah.
Any particular reason? Like JVM?
I don't know the reasoning.
I thought C would be more performant,
Yeah. I
but
think
I guess Java is more portable because it runs in the JVM.
I think so. I think that way they can have it run on different OSs, and I don't know if they have all their development outsourced to India, so I don't know if it's easier to get Java developers than C developers.
Maybe.
Let's see if copy and paste works. Is the moment of truth. Finally,
The world is right.
yes. All the skill of being a computer expert is more 90% troubleshooting and 10% like actually the working.
Knowing
it
what to
does.
do.
Yeah, exactly.
So,
Phil, I was sure he was going to have to throw that box out the window, and you were going to have to get a new one.
yeah, I think that should be good now. So now, oops, upstay. Wow, I can't even.
Zero update. Only for that, so.
Entry 11. Option not assignment.
So
You're missing your O again.
Thanks. This keyboard is quite new to me. For some reason, this is not liking this entry too. For maybe just get rid of it. Maybe it's like old remnants or something. Let me just there we go. Okay, that's working now. Now it's updating the repository to include the one that we just added to that file, which took like forever. So now we can install Docker, which is all this stuff. So container D is what Docker uses under the hood. And that is OCI compliant. And under container D uses that other program you saw called run C to actually start containers. So, oh shoot. Wait. Actually, did I add to them? Whatever. Okay, that's the wrong one. Maybe I didn't press Control C here. Must be a pain to be watching what I'm doing.
I've fumbled like this in front of customers. I do it all the time. Hate when they're watching.
Yeah, it's all good though. Okay, yes, I want to continue. So that's what container D is. Docker C, E, and Docker CLI or Docker C, CLI. So how Docker works is there's a daemon that runs in the background that keeps track of all the containers and images. And when you send commands via like the Docker command, it'll go through that daemon to actually interact with stuff. So we actually have to start that daemon. So what's this specific? No, I don't want to do that. Yeah, so the first thing we'll do is we'll run this container called hello world, and we'll see exactly what that's doing once we install it. Actually, let's see if, oops, window.
Oh yeah,
That's what I'm talking about.
it's a beautiful thing.
Here, can I?
One of the controls in F is full screen.
I think that should be big enough. All right. So do we have systemctl on here? Yeah, we do. Okay. So I don't know if you know about systemctl, but it's basically the init system for Linux, for various distributions of Linux. It's the first process that runs, and it does a bunch of other stuff. So we have to start the Docker daemon, which manages all running containers and all the existing images on the system. So to do that, we just do sudo systemctl. Actually, I'm going to see if it's running first. So status Docker. Okay, so it's loaded, and it actually is enabled to run on start. So every time we start the system, because this is enabled right here, it'll start, but it's not started yet. So we'll do that. Okay, and so usually there's an image on Docker Hub that will basically just print hello world so that you know Docker is working. So we're gonna do that. So sudo docker run hello world, and actually just to be safe, we do --rm. So it can't find it locally, so it's gonna by default go to Docker Hub, just find it. Okay, it pulled the image.
Wow.
And it ran the image. So running this image, what it does is print all this stuff. Okay. Hello from Docker, blah, blah, blah. Okay. Now, yeah, okay. So let's go up a little bit. Okay, so see how it says unable to find image, hello world, latest. With Docker, what we have here is on the left of the colon is the image name. Okay, and on the right of the colon is what's called a tag. So every image has a tag associated with it, so you can tell basically what version of the image you're running. Okay. So typically on Docker, if you look on Docker Hub, you'll see in the tags tab, every image will have a latest tag. so that if you don't know what image to get, you can always try to get the latest one. Sometimes it'll be the unstable version, but most of the time it'll be this latest, most stable version. Okay, and image though that tag is used for things like, oh, I want the ARM version of this image, so get the one with the ARM tag or something like that. Okay, so that's what that latest tag is for. Okay, and if you don't specify the tag, it'll try to use the latest tag.
Okay.
So that's why the latest tag is required for Docker Hub images.
What's ARM?
ARM is an architecture. So like this is on AMD 64 bits.
86.
Usually if you want to run this on a Raspberry Pi, you wouldn't be able to run this specific image because it's 64-bit. You would have to try to get the ARM version of the image.
Oh, okay.
So you'd be colon ARM or something like that for the
got it.
tag. Yeah.
Got
The
it.
CPU architecture.
Got it.
So Hello Dash World has to be unique. So if you wanted to do your own version of Hello World, because it's in the repo,
If you want this to be in this repo in Docker Hub,
yeah.
then actually you could make it that name, but then this image isn't a good example because so if I created an image, okay, and I called it hi, and I uploaded it to Docker Hub, then to pull this image, I would have to say Docker. So I could do Docker pull. If my username is Trevor /hi latest, okay, and that would try to pull that image from my
Gotcha. Okay.
repo, okay, on Docker Hub. So it's kind of like GitHub, if you're familiar with GitHub, where
A little
it's
bit.
like the username / the repo name, and then add the tags associated with it. Okay.
So GitHub, you have to do it that way. You have to specify the user /
Okay.
repository.
So what I'm going to do is I'm going to pull an image. Okay, I'm going to pull the latest Ubuntu image. So if I do Docker pull,
Trevor, do you want to go over what it actually did
before
you move on? If we kind of glossed over that.
okay, so it pulled. See, library is like the default Docker, like the image that Docker created.
Oh, okay. So instead of a user, in their case, this case it's library.
So when Docker creates it, you don't have to specify a username.
Yeah.
And there's several images like that, like actually Postgres, PHP. You don't have to specify a username because Docker creates those images.
Gotcha.
Okay, and so each image has hashes associated with it. So this is the short version of the SHA-256 hash, which is the digest. So it's the hash of the image. So that's the unique identifier of the image, is that hash right there, which a hash is basically you take the input of the whole image and you make it a unique value that no other image will have that hash unless it's exactly the same as that. Okay. Now we won't see this for a while, but how images work, for how Docker manages images consist of multiple layers. Okay. And every time you make a change to an image, it adds another layer on top of that image, which is what that layer is just the changes between that layer and the previous layer.
Like an overlay type of thing.
Overlay. In fact, the
Is it
file
the
system it
div?
uses is called overlay FS.
Oh.
Okay. Now, what that allows you to do is, say I pulled my high image. Okay, let's say I pulled that high image, I ran it, whatever. I'm not satisfied with that image. I want to update the image. Okay. Now, how you create a Docker image? You create this thing called a Docker file. Okay,
Okay.
and it's basically a list of instructions. We'll see how it works later. It's a list of instructions on how to create the image. Okay, let's say I open up that file and there's a command down here that I need to change. Let's say it's the very last command that I want to change. Okay, I change that command. Now I have to rebuild this image. Okay, now because of the overlay FS system where you have different layers, it's only the changes between the layers. I only have to get this layer because all these layers before it have stayed the same. So now I just have to pull this layer from the repo.
Oh, okay.
So it's kind of like Git in that it just pulls the changes.
Yeah.
But it works by doing layers of the image using, I think it's overlay FS, which is like the changes between each layer. And each command in the Docker file will create a new layer in the image. And we'll see how that works later on once we go higher level.
So if you change something in the middle, it'll start from there and rerun everything after that.
Yes.
Oh, it will everything after.
Yeah, because
Okay.
everything else
Depends on that
depends on that
Makes sense. Okay.
previous change, right?
So and that would change the hash, right?
Yes.
Okay. So just real quick.
Usually you tag your image when you create it, like with a name.
Oh.
So you have to specify a different hash each time.
Oh.
Like each
Oh,
time you
okay.
build, okay, now it's a different hash. Now I'm going to specify that different hash.
Okay.
It'll just stay the same name.
I'm gonna install this tool real quick so that I can show you what's going on with the hood. So strace, all that does is monitor all of the system calls that
Oh,
a process is running. Okay.
cool.
So I'm going to pull. So I was going to say I'm going to pull the Ubuntu image. So I'll do that real quick. Sudo, and the reason I have to do sudo is because Docker requires root privileges to pass things to the daemon. Okay. What it allows you to do though is it creates a group on your system called Docker, and if you assign like Phil B to that group, I don't have to specify sudo anymore. Which actually I'll do that right now.
Interesting.
Yeah.
Okay.
So
You have to relog in.
see what groups. So I'm not part of Docker right now.
Okay.
But if I do Docker Phil B, now if I apply that group, then now I'm groups.
Wait, new GRP is that?
Oh, maybe not. Let me I'm gonna reopen this, relog in. Oh my gosh, that's so slow.
That's Zoom, I think, or else my
Zoom.
computer.
Oh my
Wait, what does the new
gosh.
group do?
It what it should do is basically emulate relogging in and doing that, but for some reason it wasn't working.
Oh.
No.
Yeah, careful when you go all the way down. It pulls that thing up.
Okay, I'm just gonna.
Wait, you can do it right now.
This is painstaking. Whatever. Okay. Windows.
Go.
Okay. All right. And what's
You
going on?
haven't relogged in.
Maybe I have to relog in the whole system.
Oh, I figured a new shell would pick it up. You have to do a fresh login.
Yeah.
It's annoying. Can I get? No, let's leave that there.
Because that technically wasn't a login shell because we're on a graphical session.
Yeah, I always forget that. Usually I'm in a TTY because log out, log back in. But oh crap, I misspelled password. There we go. Okay. Okay, and here we see Docker. I'm part of the Docker group now. So now I don't have to specify sudo every time I do a Docker command. And just to test that, I'm going to try to pull the Ubuntu image. So Docker pull Ubuntu latest. Okay, see, that's also part of the library, which is like the Docker created image. Okay, so that's why I also ended up to specify a username /Ubuntu. 28 megabytes. And you can also create your own images from scratch. That's a little bit more complicated. Usually when you create an image, at the top of your Docker file, you specify a keyword called from, and then another image. So if I'm creating an application image, I'll say at the top from Ubuntu, and then like do stuff to that image, and then at the very end, like the command I want to run. And that Docker file will start with Ubuntu and then make changes, and that's the new image I'll have, for example. You can also start and create your own image from scratch, but to do that, you kind of have to like prepare the file system and do all this stuff so that it'll run correctly. Usually it's easier just to pull from, usually you want to pull the proper, what is it called? The proper way to do it is to only pull what you need. So usually you want to pull from a lightweight Linux distribution like Alpine or something that's really small and only put into it what you need. Because everything else will be an attack vector that, if you're security minded, everything else will be an attack vector. Like if you're installing curl and wget into your image, those can be used, get scripts, whatever. And for example, okay, so I've pulled the Ubuntu image. Okay, pull complete. There's the SHA-256 hash of it. I've got it. It's in the docker.io repository. Now to run this image, I'll show you some of the syntax. So I'm going to say docker. Oh, and notice we didn't have to use sudo, so the group thing worked.
Okay.
Docker run -i will make this image have a standard input, so I can actually type stuff into the image still, even if it's attached from my local terminal. So if I detach from this Docker container, and it's running in the background, and I reattach to it, I'll still have standard in that I can type stuff into.
Okay.
That's what -i does.
Interactive.
In ISO interactive.
Oh, okay.
In fact, I'll do the long options so that it's easy to. Okay. And then -tty will allocate a pseudo terminal to this image. And that what I will do is allow control escape sequences to work when you're typing them into the interface.
Okay.
Otherwise, you'll just see like this gibberish appear when you try to do an escape sequence.
Yeah. Okay.
Now I'm going to do --rm. So what's interesting about Docker, or what's cool about it, is it allows you to really easily troubleshoot containers. So if I didn't specify --rm and ran a command in this container and it stopped, if the container like completed the process that was meant to be run and then stopped, that container still exists. It's not running, but it exists.
Oh.
Okay. And what that allows you to do is see the state of the container after the process has run.
Okay.
So you can troubleshoot what has happened. You know, if you make it log to a log file and it stops, you can see what happens. You know, if it disappeared, you'd be like, oh, shoot, what happened?
Exactly.
But what this allows you to do is, okay, what happened? Go around the container, you know, and see what happened.
Yeah.
And then you would remove that container later. What this --rm does is make it so that when the container stops, it'll automatically remove it.
Okay.
Since I'm doing a proof of concept here, I don't need to keep the container around.
Sure.
But that's what that does. Okay. Now I'm going to --name this container. Let's see, test. And typically you don't have to specify this. It'll auto create a name for you, like some random words. And I'm assigning a name because usually, conceptually, it's nice to see what a container's name is so that you know what it's doing.
Sure.
And it can be any name that you want. It doesn't have to be a certain name or whatever. But I'm calling it test because this is going to be a test. Okay.
So you're creating a new container?
So I'm creating a new container, and I don't know how much of the previous stuff.
Oh,
did
I
you
was
do?
watching. Yeah,
Okay.
yeah.
So now I'm going to specify. I'm going to say what?
Well, yeah.
Okay. So now.
No, he wasn't.
Now I'm going to. What did I want to do? I want to.
He was in the ice maker. He didn't know.
Dash volume. Okay, yeah, dash volume. And what I'm going to do here is mount a directory on the host system into the container.
Okay.
The reason this is common to do. Okay, so remember how I said before that containers themselves are ephemeral, meaning any change you make will be destroyed when the container doesn't exist anymore.
Yeah.
If I mount a directory in, that is something from the host machine that's in the container. And so the changes made to that mount point will stay.
Makes sense. Okay.
So if I create a file in the container into this directory, it will stay when the container is destroyed.
Okay. Yeah, that's kind of the stuff I'm learning to learn is where are these boundaries that we can remain or not. Because in the context of Remedy, BMC is telling us everything you do will always get wiped fresh because that's how they decided to implement it. So, but that's really a choice on their part, right? It isn't a technical limitation. It's how they've decided to implement
Yes.
it. Okay.
And what this allows you to do is separate the data from the application.
Yeah. Okay.
So that's like almost the main purpose of using Docker is separating the data from the application. And what I mean by that is if I'm having an application that requires all these dependencies, I can build that in the image, run that as a container, mount in the data directories,
Mhm.
have the application run. Then when the container's done, unmount the data directories. All those changes that aren't important go away. And then I can do the same. If there's an update to the application, I don't have to worry about, oh, is my data going to be affected by this? I
Exactly.
can just get a new image, run it, mount the data in, and boom, you're good to go. The only thing you have to worry about is compatibilities between the application and the previous version of the application. That's the only thing.
Cool.
So that's another important thing to know about volumes. And actually, Docker has this thing called Docker volumes, which aren't the same thing as a mount point. So
Okay.
typically, you can have a mount point be mounted in from your host directory to the container directory. You can also have this thing called the Docker volume, which is this some point in the host machine mounted in as a storage location into the VM.
Gotcha. Okay.
And technically, it's located in this certain directory, a Docker directory on the local machine, but it's not really important to know where that is. And you would want to use that if you have a cluster of containers across different machines or local that you don't have to worry about, oh, what's the location? You just specify, oh, this specific volume with this name, mount it into these locations.
Oh, okay.
And the host OS knows that?
The Docker daemon keeps track of that.
Okay.
So it can say, okay, create all of these containers and mount this named volume. Well, you don't have to worry about what location it's in. It's just this
Yeah.
named volume into these containers. So there's different, they're called volume drivers. So okay, what mechanism is being applied to this mount point? Is it the Docker volume or is it just a regular mount point?
Okay.
And there's a couple other ones that are for different use cases. This one right here, what I'm going to do is the Docker volume because it's easy to understand. It's just directory from the host system into a directory under the container.
Okay.
So what I'm going to do is I'm going to mount in home fill B, so my home directory, into let's just say app. So like in the container, the root directory, the app folder will be
Slash
there. Yeah.
Okay.
And I'm going to mount it as read write. So you can mount it as read only. If I did this, you would be able to mount it as read only.
Cool. Okay.
Yeah, but I'm going to do it as read write. And if you don't specify anything, it'll assume it's read write.
Okay.
But for being learning purposes, I'm going to do the full thing. So read write. All right. We're not going to use this now, but I'm going to also specify a port mapping. So like, remember I said before, namespaces allow you to separate different groups of resources like PIDs.
Mm-hmm.
You can also separate network resources. Okay. So if you had an application that only expected port 80 to be exposed, then you could actually map that port in the container to a different port on your host system and then point your web server at that port, and that would get routed, almost like a port forwarding on your router.
Sure.
Where it doesn't have to be the same port, but you can forward that through the container boundary.
So on the host, it would be some other port, but that from the container standpoint, it thinks it's 80.
Yeah, in this example, if I wanted to say, oh, I need port 1234 on the host system to be used for this application, but if your application was fixed set on 80, then you could specify, okay, mount 1234 or forward 1234 into the container as
80. Okay.
80, as either TCP, UDP, or both.
Oh, okay.
So I'll give an example of that here.
Okay.
The long option is -- publish, and you can do, it's the host : container port.
Okay.
So host 1234 : 80 in a container. This is following our example. And then you could either do /TCP, so it'll be a TCP port. What also something you can do is a little bit more advanced. You can specify, oh, this port on this interface
Okay.
be ported.
Yeah.
So if I wanted to, instead of doing, I could do specify an IP here, so like 127.0.0.1, colon that. And what that would do is, okay, only requests going to this IP at this port will be forwarded into this application.
Okay.
Oh, wow.
So an example of this is, so on my server, I have an admin web interface running in a container.
Sure.
Right.
Yep.
Now I don't want people running being able to access that on my LAN.
Mm-hmm.
So what I do is I have a separate interface, like a VPN interface, that's running on 10.7.255.0 network.
Uh-huh.
What I would do is I would specify, okay, that 10.7.255.0 network, I would specify that the host IP for that here. So in that case, it would be, you know, if my on that interface my server was 10.7.255.1, then only if the request is coming to this interface, would it forward that port to, you know, if my my LAN IP of the server was 192.168.3.2. If I tried to you know, type that IP into the import into a web browser, it wouldn't come up with anything because it's not that network.
Exactly.
Yeah.
Cool.
So that's another thing that allows you to do, and I'll keep that here just for completeness. Okay. And now another thing we could do, I'm not going to do it, is --detach. And what that does is, instead of attaching the container standard out and standard error to my terminal, it'll run it in the background.
Oh.
And the Docker daemon will keep track of it, and later on we would be able to attach to it.
Okay.
Does that make sense?
Yeah.
So, you know, actually, yeah. So that's what that one does. I'm not going to do it now, but for this example. Cool. Those are the important options. Now we specify the image we're running. So in this case, it's Ubuntu latest. Now,
And we pulled the Ubuntu latest already, so it's not going to fetch it again.
Okay, so it would try to fetch it.
It would try to fetch it if it didn't see it, and if it couldn't find it, it would let you. It would basically error out. Okay. And it'll look on by default Docker Hub. You can specify, look on, you know, the GitLab's image repo /user/image.
Okay.
If you wanted to.
Because a part of what we'll be heading with Remedy is they run it on Harbor or Safe Harbor.
Harbor is an application that you run that you can make your own custom registry.
Okay.
So it'll probably be Remedy's
exactly
server hosting.
BNC, because Harbor, whatever.
Right.
Something
Well, I
like
think
that,
actually have you run that on prem to cache down their images.
Yes.
So I think it goes to bmc.docker.io, but Harbor pulls them down and maintains
Gotcha.
them locally. I think that's
Yeah.
what they're doing.
That Harbor is a software that allows you to host your own registry. So that's probably what they're doing. So there's the image. Now, if in your Docker file, the instructions for creating an image, you specify a command to run, then right here, if I hit enter, it would run that command. Okay. If I specify a command next, it will run that command instead. Okay. And we'll go over this. There's a couple of caveats here, but in essence, that's how it works. I'll go over those caveats when we go over what a Docker file is. But if I specify a command here, it'll run that instead of whatever is default in the Docker file.
So you could have like an initiation command or something the first time, or to. I think I'm kind of seeing how.
I'll give an example. So if I have like a web server in this container, okay, and that command will be in the Docker file. It's a command to run if I don't specify anything.
Mhm.
But let's say there's a file in that container, in that image, that I want to double check is right. And what I could do is do this and then say, bash to start a shell in the container. Don't start the actual application, just run a shell in it.
Wow.
Then it could do that. And then,
No way.
what is that file? Okay, it's that. And then,
So you could actually look at the files in the container in the image without actually starting it up.
yes. So technically, this will start a new image a new container from the image,
Okay.
and start a bash shell in it instead
Wow.
of the web server.
Yeah. Okay.
If you wanted to attach a shell to an existing, that's possible too. We'll go over that after this. But to run a custom command in an image as another container, this is how you would do it. And we'll do that now.
Okay. That's pretty cool.
So real quick, I'm gonna start another thing. So if I hit ls, okay, we see desktop documents, downloads, music, pictures, whatever. Okay. If I do host name, well, if I can spell, enter host name, we get the host name of this computer. Okay. Now, if I start this command, we have another prompt. Okay, what is my host name? wow, I can't even spell. Okay, the host name is something completely different. That's because the group, what's it called? Namespace that the host name is in has been a new namespace has been created for this specific container. And that's what a host name is in. Now, if we say what our user is, what was the command that I said? Oh, I just did host name. Well, if I did ls, now we see we're in a different location. It's a different root than the root on our system. So if I ls root here,
Ubuntu root.
I was gonna say that's Ubuntu.
then we see all this stuff. We don't see app,
Mm-hmm.
and see if I ls, we're already there. But if I do that again,
Yeah.
oh look, there's this app folder here. So obviously this is a different location.
Yeah.
So what is in that app? What is in there? Oh, there's desktop documents, downloads, music. Oh, that's the same thing as in our home directory. So that's the mount point working right there. Okay. So if I touch a file here, okay, there's hello txt, ls/app, hello txt. So the file still exists here. And if I stop this container, that file will still exist. Now, let's see. Is there an IP command in here? Okay, no. So that is an example of of me running a container. Okay.
So can you do a hostname -i? What does that show you?
This is so when Docker creates a new image, the default network will be a 172.17. I think it's /16 interface. Okay. And under the hood, that's a bunch of IP tables commands, and they're changing the routing table, basically. So real quick, I want to see if this works. But if I hit Control D, we're no longer in the container. And if I do a Docker,
What does Control D do?
It sends the shell and end of file, and essentially most shells understand that as exit.
Oh, okay.
here, actually, sorry, I didn't demonstrate this before, but let me run this container again. Okay, we have the running container. If I do a Docker container ls, you see, and let me make this bigger. Okay, here's our image. This is the command that's being run in the image. It's created this 8 seconds ago. It's been up for 7. This is the port mapping, like I said before. Okay, and then this is the name that I gave it. So if I didn't specify a name, this would be some random string of words that it created. Usually it's like 3 words.
Yeah, it's usually like 2 adjectives and a
Just some
noun,
nonsense.
like
yeah.
fancy eccentric lemurs, something weird like that.
Yeah.
Like random.
And there's a container ID. Yeah. So now also I can see what images I have too. So if I do Docker image ls, these are the 2 images we got. So there's the hello world image from before, and then the Ubuntu image.
And if you didn't name it, that would actually be like hash instead of the other repository instead of Ubuntu or hello world. If you like created an image and you didn't name it, it'd be like a hash kind of thing. That's shocking.
So here's image IDs, and here's how big they are. Okay, and this is how when they were created. So if there's an update to the image, then this might be pretty old. But then if you pull the latest image, then you'll pull the changes, and then you'll see a newer creation time for this.
Okay.
Mm-hmm.
So in being 72 megs, that's just the bare bones of Ubuntu, right?
Yeah. So this isn't like a VM where you would have all your packages, all of your helper programs, and then you run. That would be like probably a gigabyte of information. You don't want that when you're doing containers. You want just what you need.
Exactly.
So basically, you have the file system, the basic core utils, and then maybe I think Ubuntu includes some like helper ones like curl and a bunch of other stuff. But usually when I create a Docker file or pull an image, I won't go with Ubuntu because it has too much. I'll go with like Alpine or something that's just what I need, and then I'll add what I need later.
Exactly. You typically go with like Ubuntu or something if you're like using a container for like development. Like if you're sometimes you pull very specific package versions that you wouldn't want on your host system when developing something. So you create a container for it and then like bash into that container to like run what you're testing.
Yeah.
Like, that's what I do for work.
Gotcha.
But you wouldn't want that like as a distribution,
Sure. Yeah.
One.
Okay. Gotcha. That
Yeah.
makes sense.
because you have all the conveniences and tools that you use in that container.
Exactly.
So
you
you
don't
want
have to install them all just to
Yeah.
troubleshoot something.
And another command that might be easier for you to remember that does the same thing as Docker Container LS is Docker PS. It gives you the processes running, right?
Okay.
And so, okay, now here's something that's interesting. And this will give you an example of what's going on here. So if I run watch ls. Oh, shoot, I didn't pass that anymore. Okay, every second I'm running ls
Oh.
right here. Okay, so this is just for having a running process on the container,
Sure.
right?
Okay.
If I go over here and let's say that process that I just started is the service that I'm specifying in the container, like a web server or something. Okay, let's say, oh, I need to troubleshoot this running container. You know, I need to attach a shell to it, for instance. Okay, I need to see which container that is first. So what I'll do is I'll do Docker PS. Oops, Docker PS. Okay, here's a running container. Its name is test. Now what I'm going to do is instead of Docker run, I'm going to do Docker digger. Docker
Why not?
exec. Okay. The dash interactive because I want an interactive terminal.
Okay.
Dash tty because I need it. I mean, I guess it's not that important. I'm doing escape sequences, but then I'm going to say the container name. So in this case, test, because it's a name of the image instance. So you can't say that you can't specify an image name here because like, okay, what if you have multiple images instances running like that?
Sure.
It has to have a name, right?
Makes
So that's an important thing of specifying the name, because usually it'll be a super long name that you don't have to type in.
Gotcha. Okay.
Okay, and then the command that I want to run, in this case, it'll be bash. Okay, so what is my host name? Hot name. Host name. CDFE82. Oh yeah, CDFE82. Okay. Now, what if I do a PS? We have. Let me do PS AX.
There it is. There's your watch.
Notice we have PID 12. Okay. If I go to the host system and do a PS AX,
You probably peek that watch or something.
let's see if I can find it. Yeah, I'll just grab it. PSAX. No. Jeez, I cannot type. We have watch-n1ls, and its PID is 4639. Notice this is the host system.
Yeah.
And this is the container. And here, the container's PID is 12. Here, it's 4639. Okay. So it's not isolated. Well, okay. The from the container point of view, it is just that. It's isolated from everything. Okay. But the Linux kernel actually maps that PID to the host namespace. And so that's what you see here going on here is the PID still exists. The kernel can still see it. But from the process point of view, it's in the container.
Yeah.
So this is the sense that I say, oh, containers don't exist. But from the process point of view, it does. From the kernel point of view, it's just a mapping.
Exactly. So that process is still running right in the kernel, just like any other.
Yeah.
Okay.
And what's cool about this is you can still see how much CPU and all that the process is running from the host machine because it's just a mapping through. It's still running through that kernel.
Yeah.
So that's what's going on there.
That
So-
process just can't see the other stuff that you
Exactly.
haven't told
It
it,
can-
given it permission to see.
Okay. So now, who's that running as? The watch.
Oh yeah, you might want to go over users.
So I know I've read something about being able to map them and like privileged and unprivileged containers, but
So that is actually a pretty big topic that you just mentioned, but I will go over that briefly. So if I do an ID in the container, UID is 0 root. Okay.
that's its own root,
Which-
right?
Actually, it is not. So Docker, by default,
when you install Docker by default, all of the namespaces will be mapped to something else,
Yeah.
like the PID namespace, the network namespace, except the user namespace. Okay, the user namespace by default will not get a new mapping into the container, and the reason for that's default. So this user root E0 is
Yeah.
actually the root user on the system.
It is. Okay.
Yeah. The reason for doing that is if you needed to do certain network mappings in the container, that requires root access.
Sure. Okay.
And so if you didn't have root access, you wouldn't be able to really map any network stuff or share the network basically between the host and the container. So with Docker, you can actually specify, oh, don't create a new namespace for this. If you had an application like a VPN server you wanted to run on the server, you wouldn't want to just expose a port. You would want to actually have that as an interface, another interface on the server. Okay. So what you would do is tell Docker, hey, don't create a new namespace for the network. Share it with the host.
Okay.
Then when you created the VPN container, it would just create a new interface on the host because it's sharing that namespace.
Uh-huh.
Well, okay, what if you wanted to do that as, but also map the user namespace as being different? Well, if you map the user namespace as being different, all of those users will be, even UID0 would not be root user on the host system. And so you wouldn't be able to do any network operation. You wouldn't be able to create a new interface or anything if you're sharing the interface with the host because you're unprivileged.
Exactly. Okay. Interesting.
Yeah. So by default, Docker does not allow or does not map user namespace into a different one onto the container. You can do it, and there's certain applications where it would be good to, for security reasons, if you didn't want a root user in a container, that you could definitely do that. But by default, it doesn't.
Okay, and I think that's read some people online bickering that Docker's not secure. That is probably for that reason. By default, it doesn't map root.
Yeah. And so this is a big reason why when I'm creating my own or looking for an implementation of an image, I make sure that the Docker file follows best practices and only has what it needs in the container. Because if you build your image properly, you really don't have to worry a lot about, oh, I have my root user in here. What if somebody breaks in, right? You don't have to worry about that as much because you follow the best practices.
Okay.
But if you just had any old image, then yeah, you'd have to worry about, what if somebody gains root into my container? Oh, it's the same root as on my system.
Okay.
So
Interesting. Okay.
that was a lot of information. Does anybody have any questions before we
Bob,
keep going?
does your brain hurt, Bob?
Yes, my brain hurts.
It's a fire hose. A good thing it's being recorded, and I'll be here. So if you have any questions that you remember later,
we should have drew up some exercises.
yeah. So this is another reason why I like doing stuff hands-on, because if you're just doing conceptual stuff all the time, you're like, oh wait, how does that actually work?
Yeah. Yep.
So just to continue that, I'm gonna do a little experiment here. So let me see. I exited the main process here. So now the container doesn't exist anymore. And when I did that, this exec automatically did that because the container doesn't exist anymore.
The exec did what?
So the difference between Docker run and Docker exec is Docker run will create a new container. Docker exec will attach to an existing container.
Okay.
So just to give a little bit of just to get a glimpse of under the hood, what I'm going to do is where is that command? Oh, it's not in this tab. It's in this tab. I'm going to strace this, and then I think I can do this and redirect. Actually, no, I want to oh, actually, it's just going to do standard error, I believe. So if I do
What's 2 greater than?
Okay, so that's
I'll-
a shellism.
Okay.
So, are you familiar with standard error and standard input, right?
Correct.
Okay. 1 is the file descriptor for standard standard out.
Okay.
2 is the file descriptor for standard error. 0 for standard input. Okay. When you do a chevron, that curly angle brace,
Uh-huh.
by default that redirects standard output.
Got it.
If you do 2 that and then a file, that is redirect standard error. So you could redirect standard error to a different file than standard output.
Okay.
This weird ampersand thing says redirect standard error to whatever file standard output is pointing to. Okay. So that essentially effectively makes standard error go to the same place standard output is going. So this pipe right here acts on standard output.
Okay.
So first we say redirect standard error to where standard output is going and redirect both of them to T.
So
That makes
both
sense.
the standard output and standard error are now going to the same place
Yeah.
through the pipe.
Yes.
Okay.
And believe it or not, the order does matter. If we redirect standard
Oh.
output, if you can redirect standard output somewhere, then do that 2 ampersand thing, and then redirect standard output somewhere else, and standard error will go to the old place that it pointed to.
But don't worry about that. This
But
is
that's
just
That's
Yeah.
pretty standard.
This-
That-
yeah.
That's like advanced stuff you don't need to worry about, but that essentially that says standard error, go to standard output.
Thank you,
You'll
Devin.
use
Thank
that
you,
a
Devin.
lot.
Thank you, Devin. That's a lot of information. Don't have to remember
Thank
any
you.
of that. I'm doing an example here. You don't have to worry about the command I'm doing
Got
right
it.
now. I'm just trying to do an example here.
Sorry to derail you.
There would be a test, Phil.
Nope.
Hey, that's why it's recorded, man.
Let's see if I can do.
And what's T again? Okay, so T is a special program that it echoes standard input, but it also writes it to the file that you pass it.
Oh.
So if you want to see it on the terminal, but you also want it
And
for later,
Oh, cool.
yeah, it's good for that.
I
And what I was
used
saying, earlier about redirecting as root is when you do the redirect operator, there's not really, unless you're like doing that, using that as the root user, there's no way to like sudo that.
Oh.
So what basically how you get around that is you run a program as your user and then you do pipe sudo T.
Oh.
So you pipe it to the sudo T. So then
Okay.
it's kind of weird. And then if you don't want to print it on standard out,
You
you
can
can like,
find
pipe
it.
Okay.
Yeah, it's kind of tedious, but like that's how you kind of do it.
Let's see if I can find it.
It's not like because T is an actual program. It's not like a shell built in, so it's
Yeah.
like there's not really a way to do it in the shell by itself, as far as I'm concerned, as I know.
At the very top. Okay, so this file right here. Okay, so what I did at a high level is it's doing stuff right here. What I did was I'm running strace on that Docker run command that creates the container. Okay, and I haven't detached the container, so it's going to continue monitoring the system calls throughout the
Okay.
whole container lifecycle. Okay.
Cool.
And I piped that output to a file, so we didn't have to like scroll up and all this crap that you see here.
Yeah.
So that's what this is, okay? And see at the very top, we see a system called execve that that system call executes a certain file with parameters. So we see it's executing Docker, and these are the parameters that it's running. Okay, cool. It does some other stuff. It does some memory mapping, which is don't have to worry about. It's closing 3, and now it's going some stuff. There's one that I'm looking for. I'm trying to find it here. Maybe I can search for it. Let's see. Okay, clone. Okay, so it's cloning stuff. So what does clone do? Let's look at the man page for that. Man to clone. So the clone syscall creates a child process. Okay, similar to fork, but unlike fork, it allows the child process to share parts of its execution context with the calling process, such as the virtual address space, the table of file descriptors, and the table of signal handlers. Okay. One use of clone is to implement threads. All right. So obviously it's cloning its running this clone syscall a couple times to do stuff. Why can't I find it in here? Maybe I should tail it again. Let's go to the very bottom. There's a few Texas.
Wait, you did Docker run in S-Trace?
I did. Wait, let's see. Open at. Oh yeah, let me go to the beginning. Sorry. So we saw some clones somewhere in this mmap. It's opens files. Look, it's opening some shared libraries here. Okay, if I can't find it, then maybe I'll try something different. So what I'm going to do is stop this, and I'm going to RM that file that I created. So temp out, and it's I'm in the container still. That's why. Oh wait, maybe now I can see it in there. Okay, interesting. Let me try something different here. So if I, instead of doing bash, do well first let me remove that file so we can get a new one. Instead of doing bash, I'm going to do watch ls, I guess. Find it now. I still can't find it. Maybe
A bunch of escape sequences in there. Probably colors.
so doing some clones. Read.
It worked on my machine.
I know, right? Am I tracing the wrong command? Let's see, what would it be? Docker run. Yeah, it should be this.
Because unshare just, basically gets rid of the namespaces and doesn't not passing to it. Unshares that namespace.
Okay, so hold on. Don't stop, Devin.
I'm just trying to troubleshoot what's going on here. Why it's not calling it.
Let me do something real quick. I might have to. Let me see.
Oh, Jason, these guys showed me an app you could use on your phone, and you could take a picture on your phone and transmit it over ham radio, over the air, and then another ham radio could pick it up and decode that image. Yeah. So they actually got something from, Devin got one from maybe
We both did.
downloaded something from the International Space Station, an SSTV image
Really?
from the space station over the ham radio, and put their phone up to the radio, and it decoded the image and showed the picture that the space station was transmitting.
Really? It's like one of 12. It's like 12 different ones.
That's cool.
And so it went over like.
And then they uploaded it to the site and got an award for it.
Oh, nice.
But
So
here's
is
the
it
cool thing.
constantly
Broadcasting that out.
No.
It was an event that they were doing.
Oh, okay.
Yeah, it's like trying to collect all 12.
Oh, but here's the cool thing about this. If you had a line set communication between two radios, can you do this over HF? Can we do it over HF?
Okay, you probably it won't be as good as quality over HF, but
So if somebody was in
I see,
California and they were here, we could take a picture of something that we saw, like a flood or whatever, and transmit it over the air. Somebody in California could pick it
yeah,
up
there's
and use their radio and put it up to the speaker and
That's
decode the
that's really
image
cool. Wow.
over the air.
AM and sideband are more susceptible to interference, so it'll be a bit grainy probably. But what's cool though is there are different modes of SSTV, and some of which are better at error correction. They just take longer to transmit. Okay, so you probably have to use those instead of like
So back
simple
here.
one like Robot 36 or something. I have to figure it out. I haven't really played a lot around with the modes. Just the PD120 that the ISS was transmitting, and the default Robot 36 one. So I'll have to play around with it before Magic Stars or whatever. See which one works best.
So I'm trying to get them to commit to doing a workshop in Vegas at the Rising Stars conference where we take two radios, take a picture. Like, actually, the cool thing is they're talking about, and this is why I love working with these guys. They're like, okay, because the Rising Stars guy said, hey, I want to see. First of all, he goes, I want to see the space station transmit the Rising Stars logo. Not going to happen. Okay. So I said, well, we could take the Rising Stars image and transmit it from radio to radio. And these guys said, hey, how about if we take a portion of the image or different images and transmit it, and you have to download all the images and put them together to decode something.
I was just thinking like different parts of a message,
Yeah.
parts like in like an image or whatever, and then you have to download all of the images to get the complete message.
That's cool.
Yeah, and then like whoever submits the entire message gets like an award.
That's awesome.
Yeah.
I think it's getting drowned out by stuff. 'Cause sometimes when you tease stuff into like a file, it'll drown out. So I got to figure out how to filter that out real quick and see. What is it? What is it? That's trace.
Well, guys, I am going to have to call it an evening.
Okay. No
So-
worries. Thanks, Bob.
Nessa makes me get up and work early from home.
So do we want to try to do another?
We can do another. We can continue this tomorrow if you want.
Okay.
I'm kind of, as I'm going along, I'm developing a plan of what to do next. So
Okay.
we can do that.
So Jason, you're welcome to come over tomorrow. We can Zoom tomorrow. Bob, you're welcome to join. I'll record it also. And
Okay.
so
We-
can you see?
We're just
and
going to
hear
use the
okay,
same
Bob?
Zoom.
Can you see and hear okay what's going on the screen, or is it? We need to do
Yeah,
something different?
yeah, I see it. There's no way I'm going to duplicate it, but
Okay.
I'm learning. So he's helping me understand pieces of this new stuff that
Please don't hesitate
And
with any
yeah,
questions.
this is a good thing kind of that we're stopping now, because if you overnight, you're thinking about it, unconsciously, and you developing the idea, and then you get a question, you can bring it tomorrow, and then we can go over it and stuff.
yeah, what I'm going to do tomorrow is say, could you do all that again? Because I don't remember any of it.
Oh yeah,
No.
we can do that too. If sometimes you just need repetition helps, so I understand that. Cool.
Well, and so what I can do, I think I can take this recording, upload it to YouTube, and then make it privately available to us. And then
Right.
so we can go back and take a look at it.
Yeah.
Bob, for
Oh yeah,
whatever, and Jason, right?
Yeah.
So, because right now it's recording on my machine.
Okay.
So,
Yeah.
yeah.
That'd
Okay.
be ideal.
Thanks, Bob.
all right. I appreciate it, y'all. And are we going to use the same Zoom tomorrow, or are you going to have to do a
Yeah,
new one?
let's do the same one. I'll just start it again.
Okay.
Yeah.
Or something.
That'll work.